Hello all. I decided to make this video today on how to create a calibration curve in Excel with error bars because apparently in my first time teaching the class a couple years ago, we actually had an entire lab session just dedicated to making a calibration curve out of using Excel and also adding error bars. So since I didn't do that with you this time around, I'll do this in the form of a video, and it's good for you though because we can go through this and you can pause it and rewind it and do all kinds of stuff to watch it again if you miss anything, right? If anything's difficult to understand. So if you take a look at the screen I have on the Excel worksheet I have open right now, this is the Excel worksheet that I created for my students a couple years ago in instrumental analysis during the lab session where we learned how to use Excel to make calibration curves and along with making error bars. And so a few things I want you to notice first is that wherever there's white cells, those white cells are where you can input data, right? And then wherever there's gray cells, like these and all these, right? Those are all calculated cells, so they have equations in them. So the beauty of this particular Excel file is that all you need to do is type in your concentrations for your standards, which go there, right? And then type in all of your absorbances in triplicate for all your standards, they go there, and then put in the absorbances, your triplicate unknown absorbances there, and then the Excel file will calculate everything for you. And so I'm going to walk you through how to make this yourself, okay, because that's what I did for my class a couple years ago, okay? So as I said, you can do whatever you want here as far as inserting data, right, in these white boxes. And so since you're going to be you can actually change these to whatever concentrations you want to, right? And if you want to say change it to, instead of me here, I went like in increments of 5 micrograms per microliter, you could go 0, 10, 20, 30, and so on, right? And you can see how as I change each of those, concentrations, right, it changes the entire Excel worksheet to reflect the changes, including the corrected absorbances, the uncertainties of all the different parameters, and also all of the statistical tests, right? So you can put whatever concentrations you want here. And again, the reason where do you get those numbers? You get them based on whatever assay you're doing, okay, whatever calibration curve you're trying to create. So if you're doing a Bradford assay, then you're going to use your concentrations for your Bradford assay. As far as whatever your protein you're doing is, right, or a Lowry assay, they will all be different, okay. Or just doing absorbance by 280, right? A280, they'll all be different depending on what concentration and what protein you have. So I would just start out, if you're starting blind, then I would just go 0 to 25 and increments of 5. But then it's trial and error based on the assay you're doing and the protein you're going to be trying to quantify, okay, using this calibration curve. So I'm just going to undo this to get everything back to normal again, what I had before. And so first step, of course, type in your concentrations of all your standards. They go in this first column right here. And then type in all of your different absorbances, right? So you should be you should be scanning your samples, your standard samples on the UV-Vis in triplicate. And so that's why you have absorbance here at 0, absorbance at 5, 10, 15, 20, 25, and then you do it again at 0, 5, 10, 15, 25, and so on until you have triplicates of all of your samples after you do all your standard samples. And then you do triplicate of your unknown samples, right? And so here's your absorbances for your unknown samples, the 3 of your unknown samples. Once that's in place, right, you need to create cells that will calculate your corrected absorbances for both your samples, standard samples, and your unknown samples, right? So we'll look at the unknown samples first, since the unknown samples are right here, right? And it's pretty simple. Remember how you calculate a corrected absorbance? What you do is you, if you look at my equation here, right, you can just double click and you see what equation I used. I used A14, which is this guy right here, the first unknown absorbance I collected from the UV-Vis, and then I put B19. What is B19? That's this right here. B19 refers to this cell, right? And then this cell refers to this cell, where I took an average, you see here equals average of all of the blank absorbances, right? So B5 all the way to D5, right? And then so I reference this cell right here from this cell because I don't like to reference cells that have equations in them. I just like to reference cells that have values. And so that's why I put equals A19 there, right? And so now B19 has the same value. And then when you go look back at my corrected absorbance equation, it says equals A14, which is again the unknown absorbance, subtracted from it is $B $19. And what does that mean? The dollar signs make it so that when I drag my cursor down to include all the cells in a column, whatever is in the dollar signs will keep that cell the same. Whatever is not in the dollar signs, like this A14 right here, will change as as you drag down the cell column, right? So, for example, if I look at the next one, notice that A15 is the next in the column, right? And so when I dragged it down, it picked A15. But it kept B19 the same because it was in the dollar signs. And again, the reason why that is because you want to use the same blank absorbance value for each of the subtractions. You don't want it to change. If it changed as you dragged it down, right, the next one would have said B20, and the next one after that would have said B21, and those are not the values you want. You want the ones in B19. So if you didn't know that, that's how you're able to keep the same cell in an equation as you drag down to do a calculation for all the cells. You put dollar signs in front of the letter and the number of the cell. Okay, so that's how I got my corrected absorbances for my unknown, right? And then this is just right here the average of all those numbers, right? So average of my corrected absorbances, that's equals average B14 to B16. Okay. Then the K value this here, which we'll need later for doing the uncertainty of the X, right, is basically equals count the number of replicates we had, or trials, which is 1, 2, 3, which is triplicate, right? So B5 to D5, all right? So just so that you remember, this video is intended to be watched after you watch the video from analytical chemistry on how to calculate the different uncertainty parameters, like uncertainty of X, uncertainty of Y, uncertainty of B, and so on, right, by hand. And also at the end of that video, I taught you how to do it in Excel, right? So if you're unsure of any of the equations I'm using, or you're wondering where these numbers come from, make sure you refer back to that video. I say that now because that's where K value comes from, right? The number of replicates or trials. The K value is in the equation for the uncertainty of X, right? And so if you don't remember what the equation is for uncertainty of X, go back to that video or refer to your instrumental analysis notes. Okay. All right, so we did the uncertainty, we did the corrected absorbances for the knowns. Now let's do the corrected absorbances for the standard samples, right? So again, if you look at over here, it's in gray, so it's already calculated for you. And so again, I don't like to reference equations, I just like to reference values. So if you click on here, you can see how I referenced A5 there, A6, A7, and so on for all the different concentrations of the standard samples. And then if you look at the corrected absorbance values right here, right, it's quite literally, if you look at the equation, it is B5 minus B19, right? So B5 right there minus B19. The next one, B6, C5 minus B19, right, and so on. And I do this for each one of the concentrations. And so what I could have done was I could have put in the dollar sign in front of the B and the 19, just like I did for this over here, but I forgot, so I just hand typed in each of them as B19. But to save time, you could just put B19 in dollar signs, and it will hold it there for you. It won't change the cell as you drag, right? Because if I were, for example, if I just type this in like this right here, where it's B5 minus B19, right, and I pressed enter, I could just drag it down like this, right? But then it gives me all kinds of craziness right here because my B19 Let me click on that. All right, my B19, even though it says B19 there, since I didn't put a dollar sign there, it turned to B20. It turned to B21. And then before you know it, it's all crazy now, right? Because it's all in values I don't know, right? So if you do the same thing as me, make sure you either type in by hand B19 for each one of those, or you just use the dollar signs. And I forgot to use the dollar signs. That's why I just typed them in by hand, right? So I'm going to go ahead and undo what I did there, and we're back to normal. Then you might be asking yourself, what is this down here? What are these below? So to do the calculations for all of the different statistical numbers and values, it's easier to do the calculation using an equation that has all your data columnized, like in a column, instead of going horizontally, right? It's easier for them to have it, for the equation to be in the vertical fashion or the column version instead of the horizontal or the row version, right? So this is what I call my columnized data, right? Or columnized corrected values. And so all they are just referencing these up here, but just in column form. So for example, again, if I click on that, it says A5, right? A6, A7, A8, A9, A10, right? And so on, right? I didn't even have to do anything for this up here because it's already in a column form, but these guys over here, right, need to be in column form. And that's why I did this, okay? Same down here, see A6, A5, A6, right? And so one of the things you could have done was, instead of just referencing the A5 all the way through A10 over here like I did, you could have typed in these numbers by hand, right? But again, if you type in by hand, that means you have to type everything in by hand when you change it, right? So if I want to change this right here, right, the 0 to say 2.5, you can see how everything changes to 2.5, right? And even the graph changes to 2.5 as the first dot. All right, but if you were to do all this stuff by hand instead of referencing those cells, then it would not automatically change. You would have to go through and change it by hand, and that's a pain in the butt, right? And I like my Excel files to be automated. And then same with this here, right? These are just referencing those cells, right, of each of those concentrations, but just in column form, right? So here's the third, here's the one for the third trial right here. So I5, right, I6, and so on, right? I7, I8, I9, right? And you can see how it highlights. And literally, I just put these in column form just so that it's easier to do to type the equation in for the different statistical parameters. Okay. And then we have our average corrected absorbance. That's super simple. Just go there. You do equals average, right? And then it's G5 through I5 and so on, right? And so since you're going to be calculating all these anyway, right, and none of them have to say the same, no need for dollar signs, so you can just drag it down and it should give you the correct thing. So there's G6 to I6, and the next one is G7 to I7, and so on, right? Now, to get the first set of statistical data that you need, which is the uncertainty of the slope, uncertainty of the y-intercept, uncertainty of the y, you need to do the Linus function, right? And so remember, the Linus function is something I taught you in analytical. You use it here. You can type it in this equation for that if you forgot, Linus, and then parentheses, and then G5 through G22 for me, because that is all of my corrected absorbance data, right? You see how it's in column form, makes it way easier to do in the equation. You don't have to do single columns at a time. You can just do one column if all the data is in column form. And so the first is G5 through G22, which is all of the corrected absorbance data, and then comma F5 to F22, which is all of the concentrations of the standards in column form, right? And then after that, comma true, true. And that's all you have to do. You type it in, and then you should be able to get all of these 6 cells filled out, right? And the first one is the slope. The second one is the uncertainty of the slope. The third one here is the R squared value. And then the one over here, the second one on to the right, is the y-intercept. And then the uncertainty of the y-intercept, and then the uncertainty of the y value itself, right? Which are not really helpful for us because we know our y's are not super uncertain because we decided what those values would be ourselves, right? I'm sorry, we did decide what those values would be ourselves. We measured those, and we have our own uncertainty for that already. It's going to be the calculation of the x. Wait, I said that wrong. What am I saying? and the uncertainty of the y, right? And the uncertainty of the y. All right, so that's how we get all those. Now, how do we get the uncertainty of the x value? Right, the uncertainty of the x value is going to be the uncertainty of x value will be the uncertainty that is associated after you have calculated what your unknown concentration is from the unknown absorbances. Okay, the unknown absorbances, right? And so if you look at the first thing that you'll need is going to be the n value, or the number of data points. And so that's really easy. This equation here is just equals count and then f5 to f22, which is again f5 to f22. There's 18 of them there, right? So which you, again, this is a very flexible thing. So if you add more data points and you do the count thing, it will count for you and tell you what it is, 18, right? And then your degrees of freedom, easy. That's going to be the n value minus 1, right? So 0.5 minus 1, that gives you the degrees of freedom. Both of those, again, are needed for the uncertainty in the x value, right? Uncertainty x value. No, not the x concentration values, but the x, not the x concentration standard values, but the x of the unknown once you solve for that using the y equals mx plus b equation. All right, and so average of the y's, that's easy. Just go average equals average and then G5 through G22. So that's the average of all of the absorbance readings that you got from the UV-Vis, all the corrected ones. And then remember, when we do any of these uncertainties in the uncertainty x and y, just uncertainty of x for this particular one, you need the sum of the x's minus the means of the x's, right? And so that's the equation for that is actually really simple in Excel because there's already one built in. And so that equation is equals DEV SQ and then the concentrations of the standards, right? So F5 through F22. Pretty simple there. Right, so what's the x then? X is going to be the value of the unknown concentration, right, from your unknown absorbances, right, which is the point of doing this to begin with, because you're trying to figure out the concentration of your unknown from a calibration curve. So how do we do that? That's easy. We do equals, right, and then we do equals and then C14. What is C14? That's the average of all the unknowns right here. And then after that, we do minus M5, which is the y-intercept divided by the slope, which is that one right there, L5, okay? And so that's how we solve for the unknown concentration, which is great because that's what the point of this thing is supposed to be. But since we are past analytical chemistry and we are also in advanced instrumental analysis, you can't forget to do uncertainty. So how do we determine the uncertainty for the x right here, or the s of the x right here, of this x value? You have to use the uncertainty of x equation, which was that really big equation that we had back in analytical chemistry. Again, if you don't remember what that equation is, go into your notes from that class or go into the video and it will be there. Right, so this is going to be a complicated equation. So this it includes the entire equation. So we'll click on it and you'll see how crazy it is. But this is how you will type it in. Okay, if you don't know where everything comes from, again, just watch the previous video. Right, it's so long. I'm going to zoom in a little bit just so you can see it better, or maybe not. That way we can see where everything's coming from. We start out with parentheses equals parentheses M7. Right, so M7 is the uncertainty of the y, right there, divided by L5, which is the slope, okay? All that is multiplied by the square root of 1 divided by D14. What is D14, right? So D14 is all the way over here, right? And that was the K value. Remember the K value that you is the number of replicates. And so there's 3 replicates per sample, okay? And then after that, we have plus 1 divided by O5. O5 is the N, right? Plus C14 minus Q5. So C14, right? So C is right here, right? And then 14 is right there. That's the average of your unknowns, corrected unknowns, absorbance unknowns, right? And then all that minus C minus Q5, which is right here, the average of all the Y's, right? Of all the Y values or the Y absorbances, okay? All that is squared divided by L5 again, which is right here, which is the slope, right, squared times R5, which is right here. That's your sum of the x's minus the sum of the x's minus the means of the x's, right, squared, and that ends the equation. So it's super important that you type in this equation with the correct parentheses. All these parentheses have to be there for this equation to work, or you'll get an error. I'll go ahead and zoom in a little bit here so you can see the equation a little bit better, so you know what it looks like. So I got to get out of it first. Zoom into that box right there. See, and then you can see the equation there, right? All these equations have to be there. Not equations, all these parentheses have to be there for you to be able to get this equation to work correctly, right? And putting that in there, again, will give you your uncertainty of the x, right? And that uncertainty x is what you'll put into your reports and your notes, not your notes, your exam questions or whatever, where you come up with like x equals like 2.5 micrograms per microliter plus or minus, this number would be 0.245, right, micrograms per microliter. That's where that number's from. And yes, you do have to solve for all these other things first before you can get the uncertainty of x, right? But luckily, once you finish building this equation or this entire Excel file, you'll be able to do it. Okay. Then we have to do our statistical test to see if things are statistically different, like the means and the means and the standard deviations, right? And so you do that using the F table and the F calculation. So F calculation is super simple. Just do F test, right? And then that equals F test, and then F5 to F22. I'm going to zoom out again so we can see this. I have to exit. Always forget to exit. Right, so there we go. That should be enough right there. So we double click on this again, right? F test equals F test F5 to F22, right? That's the standard samples, concentrations, and then G5 to G22 right there is the corrected absorbances, all in column form. Okay, that gives you the F calculation. This is from the F table right here. If you don't know what your F table is, right, like you can look it up if you want to and type it in there from the F table, or you could just use this equation here, which is equals F interval, right? So that's equals F and then INV. INV stands for interval, and then 0.05, right? And then that's P5, P5. And you're like, what is P5, P5? That's the degrees of freedom right there, right? And so remember, we're doing a 5%. Sorry, let me say that again. We're doing 95% confidence interval here, right? So that corresponds to a 0.05% significance level, and so that's what's going to. That's why it's 0.5 there, and not 0.05 there, or 5%, and not 95%, right? Because 95% corresponds to 5% when it comes to the confidence interval and the significance level, right? All right, and so that's how you do that. And then next thing is the t-table right here, right? And so the t-table, to see your t-value, right, is pretty simple too. You can just do the t, again, interval, or INV, right? And then again, it's 5% or 0.05, and then P5, which is the degrees of freedom. Okay. And so once you get that, you get your t-value here from your t-table, right? Not your calculator, but your t-value from your t-table. Again, you could look this up if you want to on the table, but it's easier just to have Excel calculator for you. And you might be asking yourself, why does it matter to have that? Well, you need that to do your 95% confidence interval slash 5% significance level error bars, right? And so how do you do that? The first thing you have to do is calculate what that value is. What is the 95% confidence interval, right? And the way you do that is there's an equation for it from your analytical notes, right? From your analytical chemistry notes, and it's also at the end of the video from analytical chemistry, right, on how to do this all by hand. But if you're going to do it in Excel, it's quite literally just the t-table value, right, which is here W5, again, I want to put dollar signs there to make sure that the W and 5 stay the same as I drag down the column, right? All that is multiplied then W5, which is the t-table value, is multiplied by B22. B22 is over here, right? Right here, so B and then 22 right there. So that is your corrected absorbance of the standard deviation of the blank sample, right? Oh, and I forgot to say that, I guess. I forgot to say that. So before I even go over here, the time that you actually need the standard deviation for your data for this entire thing is going to be here when you figure out the error bars. And so down here is where I have my standard sample concentrations, right? And with them go the each of the standard deviations for all those absorbances for the standard samples. So if you double click on that, you can see I put standard deviation, STD EV, parentheses, and then G5, right? G5 through I5, and then so on. G5 to I5, G5 to I5, and so on, right? Sorry, not G5, it's going downwards. It's going downwards, so oops. So it's actually G5 to I5, and then the G6 to I6, and then G7 to I7, and so on, right? And so bringing us back over to our error bar equation, we can see that we're going to do W5, which stays the same throughout all these rows right here for this whole column, which is the t-table value multiplied by the B22, which is, let's see if it stays highlighted. Hopefully it stays highlighted. Why doesn't it stay highlighted? That's so weird. Let me do that again. Probably because I need to go down here and do it with this thing here. There we go. And so again, so that B22 is this highlighted box right here, which is the standard deviation of the blank of the corrected absorbances. Okay. And then all that is divided by the square root of D14. And so D14 is over here. What is D14? That is the K value, right? And again, if you don't remember what the equation is, it's in the notes from analytical chemistry, or it's in that video, okay? So we can go ahead and scroll all that down, or not scroll down, but drag all it down with the dollar signs in front of the W5 and the dollar signs in front of the D14, because we want those values to stay the same. The only one that needs to change with the column is, each row of the column is the B22, right? Because the B23 is the next one, and then the B24 is the next one, and so on, just so you know, okay? All right, so now that we have that, what you're going to do is you're going to graph your data, right? And so you can do the individual one, or you can do the average one. I did this just as a comparison to see how differently it looks. If you click, I'm not going to spend much time on this one because you won't be doing this that much, but if you click on that, you can see how I have all of the data here highlighted, right? And it makes this curve right here, this calibration curve right here, right? So you won't be doing that. You'll actually be doing, you can if you want to, just to see how your curve looks for each individual thing as compared to the average, right? So we'll do the average one here, right? That one's probably the more helpful one for everybody. And so the average is literally just the concentrations of all the standards versus the, on the x-axis, with the average absorbances on the y-axis, right? Because that's what you need to make your y equals mx plus b equation, right? So how did I do that? All I have to do is go insert graph, right? And so right up here, you go to home, which I'm at home already, right? And I already have the graph selected, but if I go to escape, now I can go back to home, right? And I can go to insert right here, and then I can do insert graph right here, right? And so when I do insert graph, you want to make sure that you choose the scatter plot. Don't choose the line graph. I know it's tempting to choose the line graph, but that's sophomorish. You're no longer sophomores. You got to use the scatter plot, and you need to use this scatter plot right here, okay? So what I'm going to do now is I'm going to switch over to a different sheet, because this graph is already made with the this per calibration is already made with the error bars on it. So I want to show you one where without the error bars already on there, so you know what to do. Okay, so I'll switch to a different sheet. It'll be all the same data, just no graph made yet. Okay, so I'll click over to sheet 3. So this is all the same data from before. My samples here, my corrected averages here, right? For absorbances here, and then my error bar calculations right there from the previous sheet, right? And so first thing to do, again, choose the XY scatter plot, and you're like, oh crap, what do I do now? It's blank, right? Well, again, this, you know, you got to do it the senior way here, which is you right click on here, and then you go select data, okay? And then under select data, what you need to do is you need to add a a series, right? You can name the series if you want to. I'm not going to do that because I already did it on the other slide. This is just to show you how to make it, right? And so then you click on that right there, and then you highlight everything you need for the x-axis. So this is x values. Click on that for the x values, and you highlight the x values. Do the same thing for the y values, and you highlight the y values, right? And as soon as you do that, you hit OK, right? You'll see your graph show up right there, right? Your calibration curve will show up right there. It looks great, right? No, it doesn't look great, because I do not like to have chart titles. That should be a table, right? Not a table, a figure caption. And I also don't like these grids, so get rid of the grids too, right? And so now that looks better, right? I'm even a little iffy about this little guy down here. I don't like that little guy down here, right? Because you can see how I actually got rid of that little guy down there. But I'm a little iffy about that, but that's not super important, okay? All right, so now that you have the dots here for each of your data points for the average absorbances versus the sample concentrations, right? Don't forget to put down your axes labels down here. Don't forget to do your y-axis label there. If you don't know how to do that, I guess I can show you real quick. You can right-click on the graph, and now once you, not right-click, sorry, just click on the graph, and then you go to Chart Design, and when you click on Chart Design, you have Add Chart Element, right? On axes, you want to do your primary horizontal, and then, oh, actually, that's how to get rid of it. I apologize. Let me go back to axes, get that back again. I clicked on the wrong one. I meant to go to axes title. Now you click on primary horizontal, and now it gives you, you know, the little thing there to type in your stuff. So here we'll do concentration, right? And then in parentheses you can do microliters. I believe that's the unit we're using per micro. Oh, sorry, not microliters, micrograms. I use U as the S for mu because there's no mu on my keyboard, just for fastness, right? Micrograms per U for microliters, right? I think that's our unit, right? Let me make sure. Oh yeah, it's right there. Yeah. And then go back, click on the graph again, like that, and then go to Chart Design. If it's not already open, go to Chart Element, and now do axis titles, and then your primary horizontal, and this one will just be ABS for absorbance, right? Easy as pie. All right, so that looks good so far. There's some aesthetic things I don't like. Like I don't like this thing going down below there. I probably would have. Yeah, it's really bugging me. I'm just going to change it. So to change this, right? To change this graph, this axis here, to get rid of this axis going below the 0 line, click on the axis. There he goes. Click on the axis, and then go Format Axis. And right now it's set to the minimum being at -0.1, right? Just change it to -0.0 and press enter, and it goes away. See, that looks way better, okay? The other thing I don't like too, like if you click outside the graph, you can see that there's a border around the graph. I don't like that either. So I would also go to graph, let's see here, where is it? Where is that? Oh, it's actually already open right here. Sorry, that's why. It's already open right here. So once you click on the graph, right, it opens up the format chart area right there, right? And see right here it says border. It says automatic. I don't like a border. I would just change it to no border, right? And so now when you click outside, no border. Looks great. Okay. Other things to note too is that all these things right here are in gray. They will not look that good when you put them onto a report. So I would change everything to black. How do I do that? That's easy. All you do is just change the font, right? So go back to concentration right there, click on concentration, go to home, and then change the color to black. like that. Whoops, I clicked the wrong one. Undo. I'm going to do this one, black, see? And then also do that one in black. Okay. Also, these tick marks here, right, are also actually, funny thing, we're missing tick marks right there. I might have to fix that in a second. But these numbers here are also in gray. You want to change those to black as well. So click down that right there, and then right here under color, it's gray. Change it to black, right? And then over here, same thing with this one. Change it to black. Right, and now you can see everything much better. Everything's much better, right, as far as those lines go. And then for the numbers right there, the numbers of the axes, I think those are still in gray, so highlight those, change them to black like that, and then highlight those and change them to black like that. See, now everything's in black. It looks much better. Okay. Now, if you accidentally did something like I just did, and somehow I lost my tick marks over here on the absorbance axis, just click back on the absorbance axis right there, and then I think you click that right there, right? This guy here that looks like a bar graph. You go to tick mark, right? And then see it says no tick marks. I would just change that to outside, right? And then major tick marks. See? And so it comes back. Okay. Now that's how your graph should look, right? In your reports. That's great. Now let's talk about the data. The data needs to have the data points need to have a trend line. So that's pretty easy. All you do is you right click on the data, right, and you go add a trend line, right, and it will automatically make it a linear trend line for you, which is what you want to have. Okay, but the other thing you probably should want to have too on here is the R squared value and the equation. How do you do that? You just click check marks right there and right there, right, and now you have the R squared value and you have the y equals mx plus b equation. Why do you need that? Well, you need that because remember back over here on this sheet, right, you needed to solve for the x, which is right here, right, and you can't solve for the x unless you have what the y equals mx plus b equation is. Well, technically you can because the Linus function tells you what it is, right, but you won't show the Linus function on a paper, right? You only show a graph or a calibration curve on the paper, so it's best to just show it right there, right? All right, so back to this. How do I get error bars on here like I have here, right? How do I get error bars? Well, it's pretty simple. Go back to the one without error bars for a second. I would just go ahead and close this right here because you don't need this anymore. And then just click on the graph again. Make sure you click on the graph. And then go to chart design. And under chart design, there will be this thing called error bars, right? It says none, error, standard error, percentage, or standard deviation. All that stuff is juvenile. Don't use any of this stuff. Juvenile stuff, they're your seniors now, okay? Not even sophomores. It's just juvenile. Go to more error bars, right? More error bar options, and click on that. And so when you click on more error bar options, two things happens. It automatically gives a fixed value of 1. That's not helpful at all because that just gives all the error bars the same value. But then it also gives you horizontal error bars. Oof, we don't need horizontal error bars. Why don't we need horizontal error bars? Because we chose those concentrations for our standards, right? So we don't need error bars for that. Okay. The only ones that we need error bars for is the Y absorbance values because we got these from an instrument, and there's always uncertainty with instruments. Okay. Well, there's uncertainty with people too, but there's going to be more variation with the instrument than there is going to be with you actually typing in the number, right? And measuring out and weighing things with a balance, right? And you know what those uncertainties are because you know how to do the uncertainty of a concentration already, right? And uncertainty of a mass, right? So what do we do to get this so that it doesn't look so crazy and we get rid of the things that we don't need? Well, first thing to do is to get rid of the horizontal error bars because we don't need horizontal error bars. So all you have to do is click on the horizontal error bar like that and then hit delete, and it gets rid of the horizontal error bars. Great, okay? Next thing to do is that you want to modify the vertical error bars. So you click on the vertical error bars and it pops up this right here for formatting error bars right here, you see, right? Make sure that you have both error bars going right above and below the data point. You also need to have a cap on each one, right? So if you click outside, you see that each one has a cap right there. Make sure they have a cap, right? So make sure you have a cap. And then you need to change it from fixed value to custom value, okay? To custom value. And then after that, you could specify custom value. So this is great because now you can specify what values you want for each individual data point, and it will go corresponding to the concentrations of each of your standards, right? And so for the positive, which is the one above the error, above the data point, go over here and highlight, right? Click on that little button right there, this little guy for the positive, right? And then highlight the error bar values that you calculated right there, right? Those are the error bar values you calculated from the previous slide, right? Or previous sheet, okay? And then click this button again, and then do the same thing for the negative values, which is the one below the data point, right? So click on that, and then highlight those as well, right? And Excel will know that which one goes with which, right? Because it corresponds to your concentrations, right, in the table, right? And you just close it right there like that, and then you hit OK, and voila, right? It's kind of hard to see the error bars right now because they're highlighted with these little blue dots, right? Not the blue dots of your data, but the blue dots saying they're highlighted. So just click outside, and then you can see your error bars right there. See, right there, right there, right there. Now, don't freak out. Sometimes your error's so little, so small, that your error bars, you can't even see them. So these error bars here are big enough that you can see the error bars. Even that one's slightly, you know, slightly obscured by the data point. But these here, these guys here, these error bars are so small that they're being obscured by the data point, right? So that's a good thing, okay? That means your error is very low on those, okay? So if you go back to my previous sheet right now, right, the one that I had before, this will be the exact same. This right here will be the exact same as my error bars over here. And the only reason why if you zoom in on this one, you can see the error bars on the lower concentrations a little bit better, is because all I did there is I made the dots smaller. I made the data dots a little bit smaller so you can see them a little bit better, right? Because I do want to show that there are data, there is error there, right? Now the the dot at 0, 0 is so small, right? Or the error at 0, 0 is so small, right? That I made it the dots as small as I could there, and you still can't see the error bars, right? So, but yeah, so that's basically it, right? And that's all you really need to do. Once again, I wanted to. It's not once again, but once you make this cool Excel file here, you can use this Excel file for any of your calibration curves that you do here in class, in instrumental analysis, in industry, in research, anywhere. Excuse me. And literally all you have to do is type in your absorbances and type in your sample concentrations and type in your unknown absorbances, and it will calculate everything for you, right? And so once you make this Excel file, I'm not going to give you mine, but I showed you how to make your own, right? Because you may have a different aesthetic than I do, right? Once you build it once. It might take you like an hour or so, maybe less, probably 30 minutes to build this to make it look as nice as mine, right? But once you do it once, you can use this for every single calibration curve you use, for anything in my class, like exams, for your research, for lab, for anything, right? I actually use it. I mean, you can use it in industry too when you go to get a job, right? It's a super helpful Excel file. Okay. All right. If you have any questions, let me know. And good luck on your exam. Good luck on your quizzes. And I will see you guys later.